doesn't mean concentrated. It means that it completely dissociates. Castro Bear is a little acronym that might help you. Remember, you don't include that water because it's a liquid in that expression. Let's work on definitions of bases, and this will help you really throughout chemistry. Of course, we've got our Arrhenius definition of acids, anything that increases the hydrogen ion concentration. And then in the base world, it's anything that increases hydroxide concentration in water. And then the Bronsted-Lowry, we have H plus donors, and then the base would be an H plus acceptor. Okay, so anything that is receiving an H plus is our definition of a base. All right, let's do strong and weak bases in water. These are reactions that you definitely need to know how to write. First of all, the strong base. What it does, it doesn't mean concentrated. It means that it completely dissociates. Some bases, particularly hydroxides, they completely dissociate. So whatever concentration you have of the original base, it's all going to come apart and give you that same concentration of hydroxide. And so this would have some sodium and hydroxide ions in solution. None of that NaOH will stay together. Now, what about weak bases? Well, first of all, strong bases you need to memorize. Here's a little trick for you. These are the group 1. Okay, group 1 hydroxides. All of them. They're all strong bases, so memorize that. And then these guys down here at the bottom, these are the larger group 2. Okay, larger group 2. Castro Bear is a little acronym that might help you, but these are the strong bases. Now, anything else is going to be weak. So get the strong ones, just like we did with acids, and then the rest will be weak. Now, what does a weak base do in water? Well, it partially dissociates, so only some of those hydroxides will come out. Now, ammonia is something really interesting. If you look at ammonia, there is no hydroxide on there. So how does it increase hydroxide concentration in water? Well, what happens is this the nitrogen in of this molecule is going to attract that hydrogen of a water and actually pull off the H plus. And so the ammonia is going to be the acceptor, and it's going to accept an H plus, and the water will be the donor and will act as an acid in this case. So this is your Bronsted-Lowry acid, Bronsted-Lowry base. Okay? Now, in solution, what's this going to look like? Well, most of it is going to be NH3, all right? Most of them are going to remain together, but some of them are going to pull an H plus off of the water, and you will have some concentration of hydroxide. So Kb is just the equilibrium constant for this base in water, and so the Kb expression is going to be the ammonium concentration times the hydroxide divided by the ammonia concentration. Remember, you don't include that water because it's a liquid in that expression. And so a Kb, just like a Ka, gives you the relative strength of that weak base. And these values are found in tables for you. You can look those up. All right, so I hope that helps you understand bases, and we will also be working on some pH problems, so hang in there.